We're looking for the derivative of a polynomial function. So we're going to use the power rule to find the derivative. So f prime of x equals derivative of 5x cubed, that's 3 times 5, 15 times x to the 3 minus 1, which is 2, plus derivative of x squared, that's 2 times 1, which is 2, times x to the power 2 minus 1, which is 1, we don't have to write 1, minus derivative of x is equal to 1, and minus derivative of 9, which is 0, so we don't have to write it. Second one, we're looking for derivative of pi squared plus e to the x. Pi is a constant number. Square of a constant is again a constant number. So the derivative of pi squared is 0. We don't have to write it. E to the x is exponential, and derivative of e to the x is e to the x. So that's our answer. Okay, here we're looking for derivative of ln x. We know a formula for this. Derivative of ln x is 1 over x plus derivative of square root of e. E is a constant number. Square root of a constant is again constant. So derivative of a constant number is 0, so we don't have to write. For the next one, we're looking for the derivative of 1 over 5th root of x. It's a good idea to write this as a power of x. Since x is in the denominator, we know that this power is going to be negative, and 5th root of x is the same thing as x to the power 1 over 5. So this function is equal to x to the power negative 1 over 5. That negative is for x being in the denominator. Now we can apply the power rule to find the derivative. So bring negative 1 over 5 down and subtract 1 from negative 1 over 5. So that will give us negative 1 over 5 times x to the power negative 6 over 5. For this next one, we just need to remember the formula for the derivative of cosecant x, which is negative cosecant x times cotangent x. Please do not forget to write x's here, otherwise these functions would not have a meaning without it. This problem is again a formula. We know the derivative of inverse sine function is 1 over square root of 1 minus x squared. For this one, we have a sum of an exponential function, which is 2 to the x, and a power function, x squared. Note that exponential functions have numbers on the base and x on the power, and the power functions have the other way around. They will have x in the base and number on the power. That's how we identify them. Derivative of 2 to the x, exponential rule, is equal to 2 to the x times ln of the space here, which is 2. Plus derivative of x squared, that is the power rule, that's equal to 2x. In number 8, the function is given as a product of two functions, a polynomial and a trigonometric. So we are going to use the product rule. So f prime of x equals the derivative of the first function. Derivative of 2x is 2 minus derivative of x squared is 2x times the second function, secant x, plus derivative of the secant x, second function, times tangent x, x times the first function, 2x minus x squared. And we don't need to simplify, so we're going to leave our answer like this. 9. Here we are given a rational function, so we're going to use the quotient rule. So f prime of x will be a huge fraction. Denominator will be 3x minus x cubed squared. In the numerator, we'll have derivative of the first function, 2x plus 3 times the denominator 3x minus x cubed minus derivative of the denominator, which is 3 minus 3x squared, times the numerator, which is x squared plus 3x. Again, we don't need to simplify it, so we're going to just leave our answer like this. For this next one, we're looking for the derivative of ln function. So, and we see that there is x squared plus 4x inside ln. So we're going to use a chain rule, and we'll start with the outermost function. So derivative of ln is 1 over x squared plus 4x times the derivative of inside function, which is x squared plus 4x, and derivative of that is 2x plus 4. And you could also write this derivative as 2x plus 4 over x squared plus 4x. Either way would have been correct. And I will do the next half in the next video.